So as you'd be aware, you've got the landing page. IMS has got two different landing pages. If you come across one with the Kia flying away, it's probably configured properly. If you come across the one with the truck or the cows, it may not be configured properly. So keep that in mind if you run into issues as you log into it and progress through whatever it is you need to do. If you get to that point where things don't make sense, or I don't know, the data is named in a weird and wonderful way, just flag it so that we can take a look at it. And we've probably missed some configuration inside of IMS somewhere.
Okay, yeah.
Pretty common on the old yarn mesh side. All right, so here's Bluff Hill. And after IMS logs in, you've got the map page. On this side, it's all geocentric. So as you'd be aware, you can click on things and get contextual information. We've got a bottom drawer down here that gives us the ability to see a bit of data depending on what we've got selected and also what view we're in. If this was the first time that I'd logged in here, I'd be in the predator control view. So the two views basically give you segregation of data. So we're segregating network and solar data in one, and then in the other, we're trying to keep it pretty clean for customers, which is basically just predator control information, trap battery status, how many possums they've killed, how many triggers, how many rebate cycles, for example. If we start up in the left-hand corner, we can go around all the settings on the map page. So top left up here, you need to make sure while you're moving around and in and out of customer instances that they say Enviro Manager. That's another good indicator as to whether or not it's configured correctly. If it says IMS Wireless Manager, just flag it for us and we'll fix it.
Mm-hmm.
A little cloud icon lets you know when preferences or settings inside your UI are being saved to your profile on the back end of the IMS server. So in theory, if you jump from computer to computer to computer, as long as you log in as your user, everything should be the same as how you left it. For example, what you selected in any drop downs, any map customization, so on and so forth. Traditionally, the site indicator or site selector has been used for customers that have multiple sites, but that's not really a thing in the yarn mesh world. So pretty much every customer should only have a single site. Covered that one before. You've got the ability to select your preferred time zone. So you can either do, site-based time zones or your time zone. So if you're trying to, we'll get onto it later, but if you're trying to share a view with somebody or trying to debug remotely and you're giving people timestamps, you just need to make sure that you guys are using a common timestamp, because I'm 2 hours behind you and Perth is a further 3 behind me.
Yeah, I'd say as a general rule of thumb, always use the customer's timestamps. Probably the easiest way to keep things simple.
Yeah, absolutely.
And going back to the location based where it's got BMET there, is that a good example of in the future, say if we were to have council based instances or government department based instances, say like Ministry for Primary Industries or something like that, that's how we could kick that off and have different interfaces for a user with multiple levels of access, and then like subcategories that can only access one of the panes or one of the instances.
Yeah, correct. The security model for IMS, this particular one, can do view-based and site-based security. It can't do data, or I don't know a good way to explain it. You can't segregate device by device data. So an example would be if I log into, let's say you've got two halves of a harbor, right? And person A is responsible for the left-hand side and person B is responsible for the right-hand side. We don't have a way of segregating the left-hand side from right-hand side if they're in the same view or same site, for example. We've only got a way to segregate data by view or by site. So we can't go down to the device level. We can't put a tag on a device and stop it from being seen in other views for other people. The new IMS that's coming has got all of that, but it's not ready yet. and it may take another 12 months for us to get feature parity before we release it on customers and I guess switch all of our customers and our data to that.
Mm-hmm.
But
And
yeah,
is that, sorry to sidetrack us, is that largely to do with hosting?
it's just the way it was designed. IMS was designed for large enterprise mining customers, and they just don't have any data that they need segregated like that. So, if you consider that the trapping efforts are potentially consumer focused or individual focused, where one person might buy one trap and contribute that trap to a community-based network, for example, there would be, I guess, a need or a reason to only show that person that trap's data that they've bought. Whereas on a mine site, that's just not a thing. The company that owns IMS owns all the data. So that's the difference between the traditional IMS use case and the environmental management one.
Mm-hmm.
All right, moving around. So when I select something, it tells me what I've got selected up here, and that's important because IMS will show you contextual data. And if you hold down, I think it's Shift or Command, I think it depends on whether it's Windows or OS X.
You can toggle through the devices in the network.
You can multi-select. So on my MacBook, it's Control. On a Windows machine, it might be something different. But see here how I've just selected 4 things, and now I've got 4 things worth of data. Make sense?
Yep.
You quite rapidly run out of map real estate or screen real estate to put these info boxes. You can either, if you need to, collapse them all, or you can actually change whether they're horizontally stacked or vertically stacked. And it's that one there. So that little icon there allows us to do that.
Mm-hmm.
I don't really know, I guess, a use case for having, multiple devices selected on this side, with the exception of with the bottom drawer here, getting each device's data into a chart so that you can just do a quick eyeball of potential problems. Like over here, you see this one device has had a connectivity hit, but the other ones hadn't. So you could do something like that to determine whether it was an individual device's problem or a network-wide problem, for example. Maybe the gateway went down or some other thing occurred. But I would say that because of all these things at this point in time had a bit of a connectivity issue, it was probably an issue network-wide rather than with an individual device.
Mm-hmm.
Cool. Well, if you want to get rid of your selections, you can select something else, or you can just click the little X and it all goes away.
Yeah.
Moving along, if you've got multiple people using the system, quite often they'll add comments to things as they do them. So an example of that might be, I went and I cleared a stuck possum, I went and I changed a battery, I went and I did some maintenance tasks, so on and so forth. And in order to keep everybody on the same page, we use asset comments to do that.
Mm-hmm. Yeah,
So
we use that at Y for all our field work.
yeah, so if I click on this gateway here, I'd probably expect no comments. We'll make some comments later and we'll review them and see how they work.
Mm-hmm.
So I suppose this is a good time to talk about the construct of an asset and the construct of an IP device. So everything inside of IMS with a name and a location and an icon on the map is called an asset. And it's a logical construct whereby the asset isn't a sensor and it's not a real thing that you can touch and hold or anything like that. It's just a container that we put real data inside from sensors. So an example of this is this gateway here, a tower asset representing the gateway at Bluff Hill.
Mhm.
And then inside of that, we have real devices, either physically at that location or associated with it in the cloud. So in this particular instance, we've got the MQTT backend broker instance, which is how the data gets married up in the cloud between the when the data comes in from the real device in the field, it goes to the
Out the
MQTT
LTE.
broker. Say again?
And then out through the LTE network via
Yeah,
MQTT protocol.
it's a data matcher basically. So data comes in from the field, and the data from the field gets associated with the IP device that is then associated with the asset, and the data ends up here inside of IMS. Then we have the Yarn Mesh Gateway. So this is the physical device that's out there on top of the mast, for example. And we have all the stats for that. And then we've got the IMS server itself, and that allows us to just do some monitoring. So everything that you see on the map, and if it's got a color, has a child device inside of it, or an IP device that is pushing data out from the field up into the cloud into IMS. So if you think about the relationship as like a parent and a child relationship, so the parent is the asset, and that's the thing that has the location and represents the data on behalf of the children, and the children are the physical devices. So you don't really have access to the child and the child's data. You only have access to the parent.
Mm-hmm.
It's a bit of a hard concept to explain, but it's basically many sensors to one interface on the map, or to one interface inside of IMS, and that interface is the asset interface. So you could have, one node on a map, one asset on a map, and inside of that could be 50 sensors. But at the highest level, after it all gets aggregated, you've got a green, a red, an orange, or a yellow dot on a map, and that's representative of all that sensor information inside that asset. Cool. Hopefully that made sense.
Yes, yeah. When you are in map view and you're downloading a KMZ, so some organizations might want to get all of the location data out just from a map view. How much of that child data that's linked to the IP device would come attached to the like geospatial locators that come out in the KMZ? Probably not much.
Yeah, this has changed a bit from time to time. There's not a lot of asset data that gets pushed into the KMZ info boxes, info fields. I haven't generated a KMZ in a long, long time. We can do that now if you like. So I'm just going to change nothing, and I'll generate the KMZ.
Yeah.
And we'll see how it opens. Of course, I don't have anything that opens KMZ.
Yeah.
But you know what can open a KMZ? IMS. All right. So if I turn off all the devices and I drop this KMZ in, see what happens. So if I only want access to the data for me, I can go load locally, or if I want that to become available for all users of this particular IMS system, I can choose add for all users, and then the KMZ's data will be available in the map layers section. So I'm just going to load it locally and see what we get. So this is representative of the data. Yep, it's a very small amount of information compared to what you get inside of IMS. And the reason for us having the KMZ exportability is so that customers can share a base level of information with third parties. Maybe you've got a contractor coming onto your site or to your land to do something for you.
But all vital sensitive information.
Yep, you can send them a KMZ with only the asset that you want them to go to carry out maintenance tasks, for example, or you can draw them a map and export that by KMZ. So it wasn't really designed to help you suck data into a third-party GIS system or something like that.
Yeah.
It was supposed to be just a basic guide for someone to navigate to where they needed to go rather than to share data.
Big picture, long-term question, say Predator Free 2050 or some government body as part of their funding model wants to suck on everyone's data and have like a global IMS account. At the moment, the devs would pull all this across in like a dev instance as a trial and then do it in the individual models, and it would be quite labor intensive from a development perspective. Or
we already have that.
Yeah.
So we have an instance of IMS that we use.
Showing me that one. Yeah.
Yeah, and this thing has all data for all customers globally.
Yeah.
Therefore, the API has all the information for all customers globally too. So this particular instance, it looks a lot different to what the customer would see, because we don't necessarily care too much about the relationships or what their network or their devices are doing in the same way that the customer would care about them. So typically you won't see a lot of the information that you see in a customer facing instance, because the only reason this exists is for the purpose of warehousing the data if anything ever goes wrong. We've got the first timestamp when the thing came online, when it was upgraded, when it was moved, all that sort of stuff that helps us sort of forensically piece together issues. And it just catches data from everything, so that if we want to try something out, or if we want to, I don't know, do something different, we can do it in here without affecting the customer instance. So this particular IMS is bleeding edge. It gets updated a couple of times a week, for example. So usually this thing is pretty buggy, whereas the customer IMS instances are always a stable release. So you can see here the functionality that's running in this particular IMS gives us the ability to see imagery over time.
Visualize imagery over the map. Yeah.
And whereas the other one doesn't.
Yeah.
So the IoT dev instance is running a newer version of IMS, again, bleeding edge stuff that we're testing in here. So a lot of the devs will come in here and test to make sure the functionality that they've written works before we deploy it on customers.
Yeah.
Yep. So when the day comes that we have to share data, and I'm not convinced that there's an easy way to do that at this point in time, contractually, it could be done through this.
Yeah. You'd almost start with an account where you have all the data and then limit things off instead of build it up from scratch.
Correct. All right, moving around. So we got to comments and then had to explain assets and IP devices. And now we're on to alerting triggers. This isn't going to make much sense until we create some triggers later. But we have the ability to monitor for certain conditions: trap trigger, flat battery, low solar panel voltage, so on and so forth. And when that condition is matched, IMS can take actions such as giving you an on-screen alert, letting you know that a thing is happening in your network or in your trapping environment that you wanted to know about. And depending on the severity of the alert, the trigger alert color will be red, orange, yellow. I forget what the fourth one is. There's a fourth one. Maybe it's green.
Might be a translucent green. Yeah.
Yep. So that gives you the ability to see, I guess, in real time while using the system that something's wrong. You can also receive an email. We do have the ability to send SMSs, but none of that functionality at the moment is enabled for Yarn Mesh.
And those triggers, while a user isn't logged in, will they cache? So when they log in, they'll get a stack of triggers showing that it represents the time elapsed since they've last logged in, or is it just real time? It
depends on the trigger. So if if you use the highest severity trigger, it will do that. But if not, it won't. If the trigger is active while you are logged in, then you'll see it, but it won't show you. You can configure the trigger so it'll self-clear. If it is configured to self-clear, it'll clear, and if you've logged in after it's cleared, you won't see it.
Yeah.
You can go, I'll show you later, you can go and check the trigger history to see how frequently it's been alerting. But yeah, triggers are fairly well customizable. So you can set it up so that it won't clear, so that every time you log in, you have to manually clear them. And realistically, given the nature of 802.15.4 and the fact that it's a fairly large network, you probably always want them to auto clear. Otherwise, you're going to spend quite a bit of time, wasting your
tasks
time.
already done. Yeah.
Yeah, just clicking OK to things that are quite capable of clicking OK to themselves. Cool. So let's say, for example, we want to show someone an interesting thing that we saw, or we want to get some help from the dev team or from me or from whatever. You've got the ability to copy the link to current view. So for example, if I come in here and I select the gateway, and I want to highlight to somebody that this is the thing that I'm talking about, I can come here, I can zoom in, I can select it, and I can go share link to current view. So copy link to current view. And then if I write my email or through Teams throw in the link, someone should just be able to follow it and go straight to the thing I am talking about.
Yep.
So, sometimes customers name things in a weird and wonderful way. And when they're talking about, for example,
we're spinning a 502
Wigs 750C.
Yeah.
It doesn't mean anything to the dev team, and I should say it doesn't mean much to me, and it means a lot less to the dev team. So if we have trouble tracking down the event or the thing that the person is talking about from any point in IMS with anything selected or anything being viewed, you can generate a shareable URL that somebody else can load and go straight to the thing that you're talking about. And it's really just a mechanism to improve support. All right. Every now and again, we get ourselves into a situation with a user profile where it becomes corrupt. It doesn't happen often, but if you get yourself to a point where basically your UI is broken, you can't load any data, everything's white, all your charts are blank, for example, you can come in here and you can go reset all local settings. So there's a inside Chrome browser, which is realistically the only browser you should be using while using IMS. We use a little tiny bit of storage inside of Chrome to keep a bunch of local settings available. If that gets corrupt, you can reset them all there and go again, and it should sync your profile from the cloud. It's sort of a measure of last resort. I would, if you get into that position where things are wide or no data's loading, you can right-click on anywhere in the screen that's not the map, and you can go inspect, and then you can come up here to the the refresh button, and you can right-click it and go empty cache and hard reload. That should be your first port of call to fix an IMS UI problem. And if that doesn't fix it, it's over to reset your local profile.
Yeah. Okay, cool.
It's pretty rare that those sorts of issues occur, but they do occur from time to time. All right, moving on to help. So we've got the ability to search all sorts of weird and wonderful help topics. And I don't know if you would have noticed yet, but as you move around the application, you get to see these little question marks. If you click on one, you get the option to go to the quick start guide, and it should take you to the point where we start talking about the asset panel, for example, or or any other thing from where you've clicked the question mark. If you want to, you can get an interactive tour as well. So you can
takes you
click
through
that.
sequentially. Yeah.
Yeah, just takes you through what everything does, so on and so forth. It's pretty handy. There's quite a lot of terms inside of IMS that might be pretty well unique.
Is there much content that needs to be written relative to the predator control functionalities with regards to support in IMS?
There's quite a lot of integration left to go between predator control, yarn mesh, and IMS. We haven't yet written any specific help topics for predator control. The framework, the IMS framework, is fairly well generic. All of our data should fit into the generic pigeonholes and shouldn't need anything added to any of the help contexts. But that said, when the day comes that we start to do very specific integrations for very specific use cases, we will write the relevant help topics. We just haven't done it yet. So if you need to contact, let's say you're a customer, and you need to get in contact with FTP, you've got a few different options. You can create a support ticket, and you'll have to create a user account so that we can track things for you. And every time you log in, basically, you'll be able to see your list of outstanding tickets and their state. You can do that through here. Otherwise, you can get the old contact FTP pane up, and you can make a phone call. What is missing from here is the specific Yarn Mesh support email, which is support@yarnmesh.ai. I'll get that added to this so that the Enviro Manager IMSs point to the right direction. But even without that, if you hit any of those contact points, somebody will point you in the right direction or fix your problem.
And the Yarn Mesh support email, is that currently just pumped to you or yourself and some of the devs, or?
No, it's the entire team receives that.
Yeah,
just so that somebody responds. It'll usually be me or Lane, the team lead, that will respond. But sometimes, for whatever reason, being busy dealing with things, it'll be one of the devs. Cool. And if you want to get to the quick start guide, which is now online, you can click that button and be taken to it. And it's, I guess, a fairly generic overarching explanation of IMS core concepts. And again, it's just a quick start guide to get you up and running, much in the same way that I guess this particular training session is that. We're going to cover off all the same things.
Yeah.
All right, moving around. So moving down, we come down here, I guess, to the time slider, which is one of the cooler features of IMS. May not be too relevant in the predator control view because, sliding back and forward in time to see a kill counter go from 2 to 3, for example, probably isn't as visually appealing as being able to scroll back and forward in time and see convergence happen. So me being a network engineer, I do like this view. I use it a lot in mining to help me understand why things have chosen certain paths. But for here, it just gets us the ability to see, at what point in time who was talking to who.
It seems like the excellent starting point for any troubleshooting.
Absolutely. Yep. Having the ability to go back to a point in time and then sort of use fine-grained controls to get to where you need to go is pretty handy. And if we want to jump forward or backward in time a day, we can click, the far end buttons. And if we want to skip forward, I think it's 20 minutes or backward 20 minutes, we can just click that. Otherwise, you can just grab the blue time slider and, move it with your mouse. Probably just depends on what device you're accessing IMS on. If it's a phone or if it's a tablet or something with a small screen and doesn't have a mouse, it might be a bit hard to grab the time slider, but it should be easy enough to press the forward backward buttons. Same with zooming. If you want to zoom in and out with something with a mouse, you can do that. Otherwise, you can go up here and zoom in, zoom out. And if you get lost, let's say, I don't know, you're cruising around the map and all of a sudden you're in Antarctica or something,
Just
you
hit the
can,
home.
yeah, you can just click the home button. Takes me back.
And from memory, we set that for a new user when we're in that like admin API admin panel.
Yeah, correct. That will be um, when we configure the IMS initially. So you can see here that this one actually needs to be reconfigured. So when I did this, I didn't realize that there'd be stuff up here.
Yeah.
So if I click the home button, you can see we've chopped off this top one here. So we might digress for a second and we'll go set that. Otherwise, I'll probably forget. So my particular user account should have some superpowers called admin. And if I go over here to the site, I can sort of cheat. You know, we used to have to set things through the API, but now we've got this button here and we've got all this auto added information based on where this view is at. So if I move down here and zoom out a little tiny bit, I can probably reset the view with a single button press, which would look like
Boom.
this. Save changes. Done. Oh, click the wrong thing. So now if I click the home button, look at that. So it's a lot easier than it used to be.
Mhm.
So that's good. I guess you as an employee, someone who wears a yarn mesh or an FTP shirt, can have that functionality too.
Mhm.
Realistically, we'll be looking to put that power in the hands of the customers. It's just early days for that stuff, and we're not sure whether that's going to bite us too hard or not yet. So,
Yeah.
you know, guys who wear FTP shirts basically have that ability.
Mhm. There's just a few caveats with having setting up yourself a super user account, aren't there? Just a few things to be careful for because your changes are global.
Yeah, so this isn't part of the super user permissions.
Yeah.
It's part of the manager permissions.
Awesome. Yeah.
So we need to steer clear of the super user because that thing has full control over everything. And if you get to that point where you accidentally logged in as the super user and you can see every chart, every dashboard, every trigger, alert, ticket, everything, and you modify that, you are modifying it as the owner of that thing, and you probably aren't the owner. So
Yeah.
any change you make using the super user will be reflected on the customer side.
Mhm. Yep.
So
Too
steer
easy.
away.
I'll just steer away. Yep.
Yep. So you need to always make sure you're using your own account, not the FTP account,
Mhm.
and you shouldn't have any trouble. Right, moving along. Don't have to touch the bottom drawer because I touched that at the start. I guess a point to note is that the cursor position in the charts is synced with the time slider. So if I want to know when a very specific event occurred, such as this little dip in connectivity, I can wind my time slider until the blue line hits the point I care about.
Mhm.
And then down here in the bottom left, I can read the exact date time that it happened.
Yeah.
So moving around, IMS has this concept of real time, like live mode, and live mode allows you access to the ability to manipulate data. In live mode, you can change things about assets and IP devices, such as locations and who's associated with what, so on and so forth. And you can only do that in live mode. Why? For forensic purposes. If you were able to go back in time, I'll just choose
As an
yesterday.
employee, you could cover your tracks and fuck with stuff and
Exactly. Yep. I've gone back to August 4th. It's not a good example, right? Because nothing existed. All right, let me just go back a day. I wait for my data to load, and while that's loading, I'll actually explain it. So you would have noticed a little blue bar loading down the bottom, and now you can see these blue bars loading here.
Mhm.
The the very bottom blue bar, it's a little bit hard to see, is the locations of things, the asset locations on the map. And then the next blue bar up is a subset of data for those assets. And the next blue bar up is another subset of data. So at any point in time, you use the time controls. And if you go outside of your window of data, we only load data into the UI in accordance with the bounds of the time frame loaded. So if I go back a day, I need to grab new data, and you'll see the locations coming now, and then you've got the rest of the data, the network connectivity, so on and so forth, right? It just loads in layers. So now that I'm back in time, and if I go and try and change something, like let's say I want to move this asset, this device on the ground, I can't update its location. I can't do anything to change its stats back in time. I can go and try and edit the asset, and some of the things I am able to change, such as its name, because if you change its name back in time, it'll be reflected forward in time. So maybe it shouldn't work like that for this particular instance. Maybe we should create a stat that allows us to change a name back in time, and from that point forward, it's the new name, and from that point back, it's the old name. Guess I've never really thought about the need to do that, because it is our hope that people make changes in real time. So, you go out to the field, you carry your tablet, your phone, or whatever, you make the change while you're out there, and, we don't lose any fidelity of data. That's the whole purpose of this tool, is to, I guess, maximize data fidelity, so that we want to do reporting or something like that in the future, we know that at that minute, on that hour, on that day, this thing occurred. It's probably not a big thing for predator control, but for autonomous mining trucks, it is a big thing. Just having a big old sneeze. Okay, so we know that we've got to be in live mode to make changes to things. If we go back in time, we can only make changes to limited things. Moving around, we've got the ability to create a heat map, and I guess this is probably the time to do UI controls. This panel here that's on the left-hand side of the application is actually called the center pane, because it's in the center of the application. If we hit the 3 chevrons up here, we slide from the map side of it to the dashboard side of IMS. And if we hit that button, we go back. If we hit the split pane button, we get both. And that's why we call the center pane the center pane. It's in between both halves. If I have the center pane collapse like I do now, there's not enough real estate in that panel to be able to show things like, the heat map pane data. The panes will pop out like this one has. And if I want to redock it, I just click that button there and it jumps back in. Otherwise, if you're using a device that's got a decent size screen, you can make the center pane full width. And if you open the same thing again, all of the controls and data for heat maps is contained inside the center pane. Same for everything in here. But if at any point in time I want to pop it out, I can just click that button there and it will pop out, and I can go put that up there. I might want access to visualize things in a different way. So an example of that would be if I go over to the logical view page. Right now, all these dots are representing latency. However, I could change that to be RSSI, for example. Or what's another good one? Device role, I think, is rolled out here.
I'll show the parents, and yeah.
Yeah, so you can see, the leader, all the green ones are routers, and the red ones are children. Yep. So the data on the left-hand side is synced with UI controls on the right most of the time. Some certain types of data aren't. This is a tiny network, and to look at, it's not very impressive. Whereas if we access a much larger one and we do the same thing, it's pretty interesting to look at. Just have to wait for the data to load. Might take a little while. Or, just might be broken in this bleeding edge version of IMS. Oh, that's what's going on, I think. No network data. There we go.
Like neurons. Yeah, cool.
Yep. So, on a little tiny network, not very impressive to look at. On a much larger network, much more impressive. Cool.
Awesome.
All right. So we've got heat maps, and I'll skip past heat maps and RF planning. I'm going to go from top to bottom down the left-hand side because it makes most sense.
Yeah.
All right. We've realized that this is how we switch from the left hand to the right hand and vice versa. And we know that that's how we split the panes, so that if we've got a large enough screen, we can generate charts and dashboarding and whatever on the left-hand side, and we can be geographically aware on the right-hand side. Okay, so the aggregate table. We haven't configured the aggregate table for Bluff Hill, and we might do that as part of this if we have enough time. I'm mindful of the fact that we've got half an hour left. We may just end up splitting this training session into,
Could almost go map interface and stat browser interface as two separate sessions.
Yeah, I think that's probably a good idea. So what we might do is aim to close out this training session when we close out the right-hand side of the app, and then whatever week's time we can do the left-hand side, or whenever you have free time again.
Yeah, that'd be awesome. Thanks, Acea.
Cool. So we'll save the configuration part for later, but this aggregate table, I'll jump into a different one that is configured, and we'll have a look to see how it works. So the aggregate table aggregates all the data for all the things up into an availability and a latency summed metric, basically. So we can see that, and everything is reporting in an upwards direction. So the gateway reports its internet connectivity and its latency, and the relay devices, the backbone of the network, report its connectivity and latency to the gateway. And then traps are the same as relays, right? But typically traps bounce through relays that get to the gateway, that goes to the internet, that gets to IMS. So you would expect the further down this list, the further away from the core of the network these devices are. The gateway is the bridge between the yarn mesh and TCP IP, the internet. So this is just a health indicator, really, and the green, the orange, the yellow, the red is configured into this thing. So I guess at a glance, you kind of know how healthy your network is. And, latency is not too much of an issue, though I would expect site-wide latency at the furthest away points not to be much higher than what this is, really. Somewhere around the 250 millisecond range is probably about as high as you'll ever see. And it doesn't really matter. That could be a second or 2 seconds, because our data will live or traverse the network for multiple seconds if required. But realistically, it's about 23 milliseconds, maybe down to 19 milliseconds per hop. So each hop adds about 20 milliseconds of latency.
Yeah.
Cool.
So if you had the absolute maximum network size, you might get up to 400 meters a second. Is that what you're saying? If you've got a ton of
Yep. So every time you go through a mesh node, so say you have a relay, and a trap, 5 devices, you'd expect about whatever, somewhere around the 120 millisecond mark
Mhm.
to get your data from point A to point B the entire way across the mesh.
Yeah.
So things that increase latency are load. So if the network's busy doing image transfers or firmware updates or some command and control thing that we do from time to time, poll an entire network for its state, for example, you'll see latency increase because you can only have one device communicating with another at one time. All these devices can't communicate at the same time. They all have to wait for clear air before they transmit, and that's what increases latency.
Yeah.
Any
And
more?
currently the maximum amount of connections per relay is 32, is that correct?
Maximum connections per relay is 511. Ours is configured to something smaller than that. I don't know the exact number, but it's in the, I don't know, in the tens, maybe 30, I think. The 32 that I think you're referring to is the router limit on the network.
Yeah, right.
So I'll jump back into Bluff Hill. So I think we're already on device role.
Mhm.
So each of these devices can have, I guess, one of 4 roles. The first role being the leader role, and the leader contains the route table and the state information for every other router on the network. It's basically the source of truth for addressing on the network. So that thing is capable of answering questions. When a device asks, how do I get from where I am to where I need to go, that device can answer on behalf of the entire network. Then the next role down from that is a router role. Here it's represented as green. Traditionally, the leader role would be represented as blue, but right now that gateway is the leader, and the gateway isn't sending that particular device role stat back to IMS. It's coming, we just haven't done it yet. So this white indicator here should actually be blue. So yeah, next one down is the router, and the network is in charge of dishing out router slots or router tokens to devices, and it's all done dynamically based on many different metrics. But in essence, if a device is a router, it'll have great connectivity to the backbone of the network, and generally speaking, is in a good location to provide downstream connectivity to either other routers or end devices, also known as children. So typically we want all of our relays to be routers, and we want all of our traps to be children. That's how you have really large, well-connected, high-speed yarn mesh networks, is when you use that particular topology.
Mm-hmm.
Now, yarn mesh is pretty smart on the back end, and it'll dynamically change the amount of router slots or who is a router to suit everybody in the mesh. So actually, it's just changed right then while we're looking at it. We see here that this device went from a router to a child. Oh no, I'll lie. It went from a sleepy device. So that's the 4th. Oh, that one did. That one there. That one went from a child to a router, and this one went from a sleepy device to a child. So child devices are on all the time. So they're on 24/7, and they are waiting to be told to come a router if needed. They use almost the least amount of power in that state because they aren't participating in the mesh. They aren't receiving any information from the mesh. The parent device, which is a router, receives all the information for the child and then proxies it straight to the child every 2 seconds, something like that. Might be less than that, 200 milliseconds. So, leaders use the most power, routers use the second most, children use the third most, but the absolute lowest, I guess, power role is the sleepy end device role. So this sleepy end device here, this particular one, has its receiver and transmitter turned off for, I think, up to 2 seconds at a time. So this thing is dead silent for about 2 seconds at a time, and then it wakes up for a few nanoseconds, speaks to its parent, which in this particular case is this guy here, I think. Yep. Polls the parent for any information relevant to itself, the child, and then goes about its business, doing whatever it needs to do, and then goes back to sleep for another 2 seconds. So the router role uses about 16 milliamp hours. Child uses about 10, and sleepy device uses about 1.6 milliamp hours.
Right.
So
yeah,
quite a decent saving. So again, the network and the firmware will try and keep as many things in the router role as possible, and then they'll fall back to the child role, and then they'll fall back to the sleepy end device role. So we're going to do a bit of investigation right now to see why this thing has become a sleepy device. So I've clicked on it. I'm going to click live, and we can see that pretty recently so right there it's a router, and it's at 3.91 volts. And then if we go forward just a little bit, we see that it's still 3.91 volts. What I suspect has happened is it's hit 3.9 volts. And IMS only receives data from these devices every 15 minutes. I suspect that in the 15-minute window, it's actually touched 3.9 volts internally on the device, and it's changed modes.
Yeah.
So it's gone into sleepy end device mode at 3.9 volts. And then every day at midnight UTC, midday New Zealand time, it comes out of that sleepy device role for up to half an hour to basically rejoin the network, to do any heavy lifting, to fire up any
updates,
flash memory, do any updates, and then goes back to sleep at half an hour past midnight or midday in your case.
Yeah. So for networks where we're going to go, if we do go down the path of no solar and 2 batteries with the Y connector, is there an easy way to just bulk default the most of the network into sleepy device state?
Yeah, so as of firmware version 26, which comes out in 0.26, comes out in a couple of weeks, the default mode for a device will be sleepy end device mode. So through the companion app, you'll have the ability to verify that it's in sleepy end device mode. So let's say, for example, you're off the bottom of the universe down there, and it's pretty dark in the middle of winter. You don't have to make any changes. You just deploy the trap because it's probably raining and you're probably cold and you want to go home. You'll just deploy the trap, and that's all you need to do. Like, you won't need to make any changes. But let's say you know that you need to make a particular device a router, and the hope is that all this RF planning gets done ahead of time in a consultative manner with the customer.
And they go with the list. Yeah.
Robust RF planning occurs, and we know that device ABC need to have the router role enabled. When you do the commissioning through the companion app, you'll just change its mode. So you'll change it out of sleepy end device mode and put it in whatever, non-sleepy end device mode, so that the network can tell it to be a child or a router or a leader as required, which is different to how we do things now. How we do things now is you just deploy it and the network sorts it out.
Yeah.
But the network won't sort out sleepy end device mode. It's a physical thing that happens in the firmware when battery voltage hits 3.9 volts. So the reason why we want to take control of that and make everything a sleepy end device node, is because the difference in battery capacity between 4.1 volts, which is how we ship the devices to customers, and 3.9 volts is quite a lot of battery capacity. So again, for these deployments where we don't have solar panels attached and we have 2 batteries and we want the thing to run for a year, we want sleepy end device mode to be enabled out of the box.
Right off the bat, yeah.
So let's do the calculation on how long we would get a device to run at 1.6 milliamps. So we've got 12,000 milliamp hours of capacity with 2 in each battery. So for 2, we've got 24,000. And then we're going to divide by 1.6 to give us how many hours of runtime before going flat. And then we're going to divide by 24 to give us days. And then we're, divide 365 to give us years. So you need to remember that the device has a role. It needs to do the thing it was sent out there to do, and it wasn't just sent out there to be asleep and report its data back. It's going to run the camera. It's going to do whatever it needs to do as per the use case that it's deployed in. So if it did nothing and just sat out there all day, it'd run for 1.7 years. If it never came across anything, okay, but the likelihood of it never coming across anything is pretty low. So, depending on how many interactions the camera sees or the PIR or whatever, will, take away battery life. So that's what we get out of the box if nothing happens, which I think is pretty good.
Should you?
Cool.
Have we modelled like a worst case for these traps where we'll run 2 batteries and it's going to sit out in the watts with no solar? Have we modelled the highest draw that we could expect?
It's really
quite a lot of variables.
Yeah, it's really based on the interaction rate. You get the birds that fly into the traps in the morning and in the afternoons, and you might get 20 birds flying there. Which to the trap node doesn't look any different to a possum or a rat interaction in terms of power draw. So we're doing some work at the moment to set ourselves up for success with sleepy end device mode when it becomes the default deployment mode. We're going to disable the PIR during the day and at dusk, and only do it during dark hours to save battery life. Now that'll be configurable, but out of the box, that's how it will be. The trap won't do anything at all during the day, or the trap node, I should say, won't do anything during the day. And it's all just around the amount of power that we are burning to interactions with birds, for example.
Yeah.
A lot. There's a lot of unnecessary imagery going on. Another thing we've done to combat that is add bird, like just generic bird, to the AI model. So we may be in a position in the future where it'll, when the PIR sensor detects movement, it'll wake up, take a photo, and if it's classified as a bird, it'll shut back down again for half an hour, for example. And away we go. So the hope is that if it wakes up and takes a photo and it classifies possum, rat, mouse, whatever, it'll then just do what it needs to do. And if that happens to be in the middle of the day, then so be it. So yeah, got some options coming.
Awesome.
All right, moving on. We've done the aggregate table. So assets are basically asset options. So asset options, as you see them on the map there, and there's a heap of things that we can change. So the first thing that anyone should change, again, this is I've used this quite a lot, so it's configured for me. Whereas if a new user were to log in, wouldn't really look like this. So the first thing you need to do is go to Assets, Map Options, Visible Radios, and by default, the visible radios are set to active connections. Active connections are the visualization of the path that the data is taking to get out of the network. So what we see here is this router is connecting to this router that is connecting to this router
Going back to the gateway. Oh no, to another
that
router
is
then
connecting
gateway.
to this trap, acting as a router to the gateway. That's the path the data's taking inside the network. Why? Because the network and the mesh protocol prefers high SNR links with low bit error rates first. And that doesn't always equate on the map to something that makes sense to your eye. Like this doesn't make sense to me. But the algorithm inside the mesh has decided that this is the absolute best path for data. And it may be that
even if it's slow, like even if like I would imagine that one that's acting as the router is sitting in fairly low gradient bush with a lot of foliage in the way of the aerial. Like, let's see what the RSSI is. Can we visualize that from there to the gateway?
Sure. So if we change our visible radios to be either active chipsets or all chipsets, you should be able to see that. So as of the last data update, the mesh is reconfiguring itself at the moment, and it's decided that, I don't know, maybe the winds come up, maybe it's raining. This device has sort of been chopping and changing its roles, probably as the rain falls or as the wind blows or whatever, right? But if I go to that point in time where it is making a link to the gateway and I click on it, I can see that the connection SNR is 12 dB, which is the start. That 12 dB is, I guess in some circles, 12 dB is a lot, but in yarn mesh, it's getting to the point where it's going to become a problem. And this is represented by the yellowness in the line rather than it being green.
Yeah.
If we go click on this one, you can see that the SNR is 7 dB. So anything less than 10 dB, and it's a pretty bad link. Cool. So to truly visualize the mesh and the options for mesh connectivity, you need visible radios set to all chipsets or active chipsets. It's a big one. Otherwise,
you're missing
you
just
chase your tail trying to understand what's happening.
Mm.
Cool. So moving down the map options, we've got the ability to visualize asset data using this drop down here. So if I want to change everything to SNR right now, we can see the SNR of the links or the upstream connection displayed underneath every asset. And again, mine's already configured, but yours won't be. If you go here, label asset by default, it's name. But what you want is color by value.
Just makes troubleshooting 10 times faster.
Yep. So I'm going to change from SNR to latency. So now I can see the latency for the entire network. So we can see here that this guy,
382 milliseconds.
Yeah, he's having a pretty bad time. Don't know why. It's probably just flipping around between who it's connected to. And that's exactly what's happening. There we go. Cool. So we can chop and change data in any way that we want. I'm not going to go through all of these because they should be pretty straightforward, and at your own leisure, go through, choose whatever you want, test whatever you want. And if you get into trouble and if you can't find your way back out, go up here and reset your profile.
Yeah.
We've got the ability to show the legend for what all the colors mean as well. So if I click on this, I can see that asset icons that show these colors should match up with, in this case, latency of these values. So yep, this guy here is 1215. He's between 700 and 1400. And let me move around a bit. Yeah, whatever. He's 43 now, and of course 43's in there.
So you could see that, you could visualize that tipping point of, oh, this device is actually really close to going to sleepy end device based on its connectivity.
It won't go into sleepy end device mode based on connectivity. It'll only go in there based on battery voltage. So sleepy end device mode is purely to reserve the last bit of battery.
Yeah.
So if I change that to battery voltage, you can see that it's just right. Actually, it needs to be updated now. So as of the last version of firmware, you can see there that it used to go into sleepy end device mode at 3.83 volts, but we bumped that up
With 3.9.
0.07 of a volt, so 3.9. So I'll change that. I'll take a note. All right, it's a mental note, and I'll get that done. Cool. So yeah, the legend's pretty handy when you're trying to work out, what do all these colors mean? It's just
yeah, for sure.
All right, moving down, map layers. So Bluff Hill was kind enough to give us some high resolution imagery, and you can see it there. Like you can see this big patch here of high resolution imagery. If we get rid of that, it's just whatever our map vendor provides us. And it's usually pretty low resolution versus a bit different.
And importing terrain layers and feature layers and stuff would be a good topic to cover in our next catch up when we go through the stat browser, etc.
For sure. There's no real ability for the average user to add a layer. You have to be a manager of the system.
Yeah.
But yeah, I can take you through that. It's quite simple most of the time, and when it's not simple, it's extremely complex.
Yeah, okay.
It's a GIS thing.
Yeah, for sure.
I'll explain it all to you. Like maybe Cool. So let's say, for example, I have a imagery layer that has a certain amount of transparency or alpha added to it. You can see here you've got the ability to drag these two tiles up and down. So if I turn these both on, you can see now that, unfortunately, this particular layer doesn't have any transparency, right? It's fully opaque. So it's just plonked on top of the other map. But if it was transparent, you could move the transparent layer to the very top, and you could, visualize roads, for example, or existing trap lines or whatever. But if you want to change that, say you've got two layers with transparency, for example, you can just grab the tile and drop it on top of the other one. Moving down, surface layers. So these guys have got high resolution surface modeling. Let me turn on this, and we'll turn on 3D, which I probably didn't explain before. So this little globe thing here allows us to go into 3D, which then
it's command and drag on a MacBook, isn't it? To
control, I think. But right now, it's upset about something. Been having some internet issues lately. So IMS caches quite a lot of data in the background. If you're on like my internet at the moment, it's quite a lot of packet loss. But what doesn't work well is sucking in the 3D tiles. If you've got a lot of loss in the background, you probably just have to refresh your page. All right, cool. So now we've got 3D terrain turned on. These guys have provided us with really high resolution LiDAR, I think. Yeah, 1 meter LiDAR. So so you can make out the trees, right?
Yeah.
It's not a good representation of how it truly looks, but LiDAR bolted to the bottom of a plane, looking down, flying over, this is what you get. To give you an example of the difference between high resolution terrain for the purposes of RF, what's happening here? RF planning. Here's the difference. So if I go to RF planning and I turn on click mode and I click beside these trees in a high resolution with a high resolution surface, it's going to look terrible. So if we were to plonk a relay down there or a trap or anything like that, this is the expected connectivity. And I would say that's pretty accurate. Now, if we switch to, lower resolution terrain, the stuff that's, generically provided, don't even know. I think I clicked here somewhere, didn't I?
Yeah, just beside the trees to the east. Yeah.
Oh, there it is. Yep. So I'll click again in the same spot and we'll see the difference. Didn't work. Give it a sec. Well, that's broken, and I'll have to find out why. Shouldn't be. Maybe we disabled the layer. Is it flat? No, leave it with me. There's a bug. I'll take another mental note.
So if you're in a lower resolution terrain model, you expect better connectivity mapping.
Pretty much, yeah. Yep. The
all those tiny little peaks and troughs and differences in the tree canopy just aren't mapped in.
Yeah, correct. The actual surface isn't really taken into account with the digital elevation model. It's literally just ground height. Doesn't take into account buildings or trees or anything like that. So if you do mapping with the generic cesium ion provided terrain or a non-surface model, the RF propagation model will always look far better than using a surface model. So I would recommend to use the surface model where you can, but you just need to use your common sense in that according to the surface model, the trees, for example, are like the ground. The propagation model won't penetrate the ground, but it will penetrate trees.
Life it will, yeah.
So, one's got the rose-colored glasses on, and one's well and truly on the hate train for RF. So it's somewhere in between. Cool. All right, moving on. So what I missed before in assets is how to search for an asset. So for example, in here I can do a partial match on an EUI64 or a MAC address. So EUI64 is the thing that is in the name of the IP device. This part here, for example.
Just use those last 4 digits. Yeah.
Yep, use the last 4. If you've got the companion app, screenshot or something like that from when you deployed the trap, and you need to find the thing on the ground because for whatever reason it didn't get a GPS location, you can just search for 8E15 like this.
Yeah. And you can search tags and stuff in there as well.
You can, but you can't search tags from the asset type view or pane. You have to move to asset tags or IP device tags or types or whatever, and then you can search for it. Yep, if I want to, I can double click on the asset name and it'll take me straight to it. So a bit of an easy way to navigate, where's my thing? I guess these are in the workshop and don't have a location yet. If you want to, you can toggle visibility of things off and on. So now this is just the high-speed backbone network. Now that I've gotten rid of all the traps, it just leaves me with the gateway and the relays. So if we then change the map options to be something like, what's it called, device role. When we look at this with just the high-speed backbone network, we hope that everything we see is green. And if it's not, we've probably got a relay in the wrong location. Cool. Moving back to zones. I guess the ability to have zones would be more beneficial for some rather than all. I'm not too much of a fan of zones. I find them difficult to use. However, you've probably got quite a lot of experience using zones at work.
Yeah, that's how we mapped all of our and prioritized all of our field work.
Yeah. So I think for the average customer, zones aren't too helpful. For a large organization like Wire, they're probably a lot more helpful than a two-man team, for example.
Yeah.
And you can use zones to segregate information, data, areas, whatever. You can use them to pivot reporting data so that you can report what happened in area A versus area B, for example. Maybe that will be relevant, but for the purposes of this, I think it's probably a bit too confusing at this point in time. And you already know how to use it, so we might skip this one.
Yeah, I think that sounds good.
Cool. So try and wrap up real quick. Have you got another 5 minutes?
Yeah, I sure do. And with RF planning, the best thing for me to go over would be like default presets when I'm developing an RF plan, like ground model heights and stuff, what I should be using.
Sure thing. Cool. Let's attack that then. So RF planning, what I was using before was called on-click mode. And basically you just turn on click mode, and any way you click, it'll give you the propagation model for the default settings. And if we look at the default settings, we can go edit on click mode. And my computer is probably having a bit of a heart attack while it generates all that, all the model. The thing that's different about IMS compared to other systems is that when we interact with data like this, like terrain heights, we do propagation modeling, for example, it's all done using the computer that you're using through the browser. It's not sent off to the cloud to come back as an imagery layer, for example. It's generated on the computer and rendered by the browser. So if you've got a slow computer, it might take a long time, and not much might be usable while it's crunching numbers.
Yeah.
Cool. So I've just done that. I have now I got the propagation model for on click for this point that I clicked on right there, and it's as per these settings here. So these are correct for yarn mesh. So default heights are set about 1.5 meters. TX power is always 20 dB.
Okay, cool. Let's step back and treat me like an absolute idiot that I am. What does TX/RX stand for? Okay,
so it's the point of view. So the point of view of the transmitter and the point of view of the receiver. So two ends of a connection. And in this type of mesh, both ends are the transmitter and receiver, because one will transmit and then the other will receive, and then that one will transmit and the other will receive. So you only get end-to-end connectivity with a round trip where the packet of information goes from one end to the other and the response comes back from the other to the far end. So, you can think about it as near end, far end. The near end is the transmitter and the far end is the receiver. And then, of course, it switches straight back to get the return path of data.
Yeah.
So basically, it's just both ends. One end is a transmitter and one end is a receiver. So with the purpose, I guess, to ease the explanation, if we think about data coming down from the cloud, the gateway is the transmitter, then the relay is the transmitter. Let me do it differently. The information comes down from the cloud. It's transmitted to the gateway. Gateway receives it. the gateway transmits it to the relay receives it, the relay transmits it to the trap receives it, and then the response comes back. The trap receives it, trap transmits it, relay receives it, relay transmits it, gateway receives it, gateway transmits it, IMS receives it. Hopefully that makes sense.
Mm-hmm.
So these heights here are both the same because of what I just explained. For the outbound path, they're the transmitter. For the return path, they're the receiver. And their height's the same both times.
Yeah. And as default, you generally 1.5?
Generally, yeah, generally. So maybe it's closer to 1.2, but we're just giving a little bit of fudge factor to account for the surface model or the terrain.
Mm.
And you could make it, you've got to do a bit of thumb sucking and then a bit of on ground testing. So if you go out there knowing that you've done your desktop RF survey ahead of time and you go out there and you test your hypothesis as to whether or not something can or can't communicate, and it's way better than what you anticipated, you would generally raise the height or the power. But our power is static, right? It's always 20 dB on the transmitter, and the gain through the antenna is always 5 dB on the transmitter side and always 5 dB on the receiver side. All our antennas for all our devices are identical, and all our transmit powers for all our devices are identical. All our chipsets that receive the data are all identical, and they all have a, what is the correct word? Receive sensitivity of about neg 97 dB. So we cut this off at neg 89 for the purposes of making it look worse than it really is. So if we underpromise and overdeliver, we're in a far better position than if we overpromise and underdeliver.
Yeah.
So an example of that would be if we set this to neg 97 and we did all our RF planning, and you put two things 3 times the distance away, and it was raining and it's cold and it's yuck, and you get all the way out there and you bang in your relay and it doesn't make a connection, you're going to be pretty sad.
Yeah, yeah.
So we limited it at neg 89 to make sure that when you get to the other end and you bang something in,
You should have something.
It should have connectivity. Or more to the point, when you get to the other end and you can't actually put the device exactly where you wanted to, and you have to come down a little bit from a high point, it should still connect.
Mm-hmm.
And that's just my methodology as to keeping customers happy and limiting support calls.
Yeah, yeah.
And plus, you don't, just because you can do a 100-kilometer link point to point doesn't mean you should.
Yeah, absolutely. Yeah. Now, those two terrain heights of 1.5, will you play around with them depending on the quality of the surface model, or 1.5 is always a good standard?
1.5 in reality is about where the antenna is off the ground.
Yeah, yeah.
Maybe it's a bit lower, maybe it's a bit higher. It's
Mm-hmm.
just really where the antenna is above ground. But again, it does depend on the surface model or the digital elevation model.
Yeah, makes sense.
Cool. So let's repeat the exact same on-click plan, but now I'll raise the heights to be 15 meters. We would expect that this jagged circle becomes almost a perfect circle, up to the point where the transmission clips the ground.
Now, I'm going up on a mental tangent here, and it might be a dead end, but if we are, say, building a network where we have something like Takinga, where we have a peak with a bunch of spurs coming off it in dense bush, and we decided to put all of our relays on telescopic poles, you could almost RF plan it in 2 stages, where you do an RF plan at 3 meters for your relays, and then could you do an RF plan knowing that your relays are going to be at 3 and then your traps are going to be at 1.5?
Absolutely. Yep. So that's that's something that you can bake into a real RF plan. Again, this is just on-click planning. It's meant to be quick and dirty. But yeah, doing a real RF plan where the transmitter is attached to the real asset with the real asset's configuration. That's basically what you're talking about. So let's say, for example, I'm trying to get this thing to generate a perfect circle, but maybe 15 meters wasn't high enough to overcome the terrain. So I've changed it to 50. I would hope. No, that didn't click. I would hope to be able to, represent a perfect circle of connectivity. I haven't been here. I don't know how high the terrain is. I'm just guessing.
That's quite rolling terrain.
Okay. It's taken a while. My internet might be taking hits. There we go.
Oh, sweet. Pretty good.
Yep. So that's the relationship between transmitter height and the ability of the propagation model to see more. So I'll change that back now to be 1.5. Get rid of this. So on every asset, you'll see the height. So the default height for an asset is 2 meters. And I don't know whether that was changed from 1.5 or, as per whatever RF planning Jono did, because he found that to be more accurate. I'm not sure. But realistically, if it's 1.5 or 2 meters, it's not a huge change. If that was 20, I'd be concerned, but 1.5 to 2 is no big deal. So getting back to your point, how you do a perfect RF plan as per the devices on the ground. Every time you deploy an asset, you set its actual height above ground here. So that when you create the transmitter and you attach it to this device, this asset, the transmitter will inherit the real height above ground that you configured in here. All right, so we've got a global RF plan that doesn't have any transmitters set up. So I'm not going to mess with the global RF plan, considering this is a customer site, and when Jono does training or whoever, that will be configured correctly. I'll create a new RF plan, and I'll try and cut as many corners as I can to just demonstrate the fastest way to do it. So I'm going to call it ACES plan. Now it says here, would you like to add transmitters to the new plan? I think this is working for the yarn mesh devices, but it hasn't been beforehand. So we'll see how we go. So I'm going to say yes, and I'm going to create transmitters for only these asset types. So I'm going to do the backbone network first, and I'm going to do relays. If I wanted to do the entire network, I can do relays and whatever makes sense, gateway and traps. So I'm just going to do the backbone part of the network, just for illustration purposes. And then only with IP devices of these types. We only have one type of IP device, so we don't need to worry about it, right? We can just say any. Or we can specifically choose yarn mesh device or yarn mesh gateway. So I'm just going to choose any because it's going to choose both. And then only for radios of this frequency. We only have one frequency. I'm going to check the transmitter template. So this is going to create generic transmitters, and then we're going to associate them with the actual assets. So this is the generic new RF transmitter template, and it looks like that. So I'm going to change this to be 5 and 5, 9, and default height above ground of 2 meters, because that's about right for the
relay. Yeah.
And I'm happy with the rest. And I'm going to click save and close. And now I'm going to go add transmitters. And what I should get is a blue dot for everything that's a relay and a gateway. I'm going to hide all of the devices that aren't a gateway or a relay. it doesn't matter. It's just, to make it less cluttered. And I'm going to click add transmitters. Cool, it's working. You're trying to create a total of 7 transmitters. There are 7 new for the selected criteria. Do you want to add 7 new? Yes. Cool. So now I have generic transmitters placed above assets. Now I need to go and associate the transmitter with the asset. So this device here is that one, C049. I'm going to click the transmitter. Why not in planning mode? Oh, interesting. Okay. So functionality for RF planning looks to have gotten quite a lot better. So see how these are auto added?
Mm-hmm.
It's auto added it for the asset, whereas traditionally
Before you
up
had to
this point,
associate it.
yeah, you had to go and manually add it. So this is what I was trying to get to, this pane here. And usually, the old way, you click on it and this would pop out. And then from this asset list, you'd actually select the one that you wanted, but it's done it automatically. So that's great. So it's heaps easier than it used to be. So we don't have to worry about any of that. So
Cool.
now we actually have legitimate transmitters with legitimate heights and names, and all we need to do is generate the plan. So I'm in the plan, I'm in Ace's plan, and down here I go generate coverage. And we wait.
Couple of minutes.
Yeah, it should return in about 30 seconds. But that's provided you've got a relatively fast laptop and relatively fast internet. You can see up here that all the data is transferring. So basically, we're just slamming the map server to pull down the tiles to then generate the coverage. Cool. So this is what our coverage really looks like, more or less. I would say that this is pretty accurate. And if we turn the traps back on again, we can kind of see why some of these traps, hang on, I'll change my map options to be something like RSSI, for example. Connectivity, sorry. What's going on here? I'm changing the asset. Whoops. Where are we? Column by value. Here, Wi-Fi connections. Okay. So we can see that devices with low RSSI or low SNR links typically sit in these areas where the RF propagation model says that they might have a bad time. Now, I need to remember that we make the RF connectivity piece look worse than it is for the reasons I said before. No one wants to get to the other end of somewhere and not be able to get to a link. We should always under promise and over deliver, and that's what this is set up to do. Cool. Seems pretty accurate to me.
Yeah.
And that's how we generate a proper RF plan for the devices that we care about. So, as I said before, we're changing the default role of a device to be sleepy end device mode. And the RF plan that I've just done takes that into account. We're not visualizing the mesh connectivity that these traps are currently providing the network, because in the future, when this becomes a 500 device network or 1,000 device network, it'll only be the relays that have the router role, which is what this RF plan is. So keep that in mind. If you do a RF propagation model for the sites, I would go out of my way not to include any traps.
Yeah. Awesome. Future-proof the whole thing.
So we've got a couple of different RF plans that we can do. The only two that are really relevant for us are RSSI gradient, and that's really about it. So overlaps are kind of important, and I'll show you why. So what we want to do as people who design and deploy networks, we want to ensure that any device that we deploy out in the field can be served connectivity from at least two different places, two different relays, for example. And this overlapping coverage plan will give us that. So each device's propagation model will be a color. Yep. And what we want is a dark color, meaning that two different things or more are providing connectivity to that point on the ground. So we can see here that that pretty much all relays are deployed in a good location, where if one of the other relays that's providing connectivity to it goes down, it'll just be served from another relay. Yeah. So this is a pretty handy visual indicator to know whether or not your relays are deployed in the correct locations. And again, relays should be on high points, so they should always be served from more than one other device.
Yeah, no, that's a really good point, though. Something to check, like just to check for network redundancy.
For sure. And again, if you want to look at the legend, it's just there to the side. You can pop it out and you can see what the propagation model is telling you. So this was for the one before. So any model that you generate, you can just turn off and on inside your session.
You
don't have to regenerate them. Cool. Look, that's the real quick version of RF planning. And I guess it can be really quick these days because the IMS integration with the yarn mesh stuff has improved quite a lot over the last few months. If I had to show you how to do all of that manually, we'd probably still be talking well and truly into this afternoon.
Yeah,
that's good.
Yeah, that's cool. That's nice how it auto assigns to the assets too. Like that's real easy for the end user.
Yeah, absolutely. It's been, quite difficult for us to do all of that for the user up to this point because of naming conventions of things.
Yeah,
just
laborious. Yeah.
Yeah, absolutely. So quite a lot faster, which is good. And heat mapping. This site hasn't generated much data yet, and I'm pretty sure you're all over heat mapping. So what I will try and do quite quickly, because I'm mindful of time, we're well and truly over. I will try and just generate a heat map of possum interactions with traps, and we'll go from there. So I'm going to clear my RF plans. And what I'm going to try and do, I've still got one selected somewhere. What's happening here? Oh, cool. I just had to click out of the actual plan to get it to release the transmitters. All right, I am going to try and generate a heat map for possum interactions with traps. So for data, I care about possum something.
Predator, maybe?
Yeah, the view is wrong. So I'm going to switch to predator control.
Possums.
Yep, change to possums. And that's all I need to do there. Grid size doesn't matter right now. It's basically how many map tiles represent how much data. Sync with start and end of timeline. So this is just going to use the data that's here in this time slider, and I don't know if the site killed any possums last night. So let's go back to last month. All right, sure. Gone back to last month, and we've got 31 days of data loaded in there, which is good. Filter by IP device type, doesn't matter for this. Filter by tags, doesn't matter for this. Possums, show all, max data points is 75,000. I mean, that's a lot of dead possums. You can obviously increase that if you need to, but realistically, no one's killed 300,000 possums. Filter by selected. So if I want to select something and I've got that option ticked, it'll generate the data just for that device. So I don't want to filter by selected. I don't want to limit location interpolation, although it shouldn't matter for this particular piece of data. So let's say I wanted to visualize a person walking out there in the field who's carrying a PLM, for example. If I click limit location interpolation, the points that are plotted on the map will be exactly where there was a GPS location for that device at that time. And if I untick it, we can kind of interpolate location on the ground based off time between point A and point B. So IMS will fill in points on the ground using speed over ground and time to know that, well, you know, a minute into the walk, this person made it that far. 2 minutes, they would have made it that far. 3 minutes, they would have made it that far. But realistically, if you've only got a point here and a point there, and you have that turned on, you'll only represent a point here and a point there. Up to you whether or not you use it. I'm going to turn it off. We don't have any hidden devices here. So if I was up here and I had things hidden, this would allow me to represent data for hidden devices. So whether they're hidden or not doesn't matter. A mobile, so I don't know how we're configured on the back end to deal with a mobile. Basically meaning only static data. I think that traps can move around, you know, according to the schema for the device. So I'll do it. To
include
I'll do it without and see how we go. Last time I did this, maybe a month ago, heat mapping was broken. I don't know if it's fixed yet. I've done wrong. Let's try this. Okay. So there we go. We've got our answer. So we need to have the immobile box ticked, meaning that we only take into account data from static devices, and a trap is a static device, as in doesn't move. Even though it does move around the map when it's physically moved, it's not a mobile device like a mobile
like
phone or a PLM or a truck.
Yep.
So that we need that. And basically it's saying here that we've got 87 counts of data. Now that's pretty high. I wouldn't really expect that much. So let's see what's going on. If I go and I hide everything, we're left with where possums have been killed, apparently. Don't believe that for a second. I think I know what it is. The traps weren't cleared when they were deployed.
Oh, so it's getting the old count off the PCB.
Yeah, it's got the original count data being added into the mix. Yeah, look, 25 pump cycles. Not a chance, right? I've been out there for 25 days. Well, as of this, from this month forward, the data should be correct. We're just 6 days into the month, and I don't know what they've done. But, you know, let's do that again. I'm going to use hidden this time because everything is hidden, and I'm going to change my grid size to be extra large. So now we can see where apparently we've killed possums. And again, this isn't where we've killed possums. It's just the device counters weren't reset when they were put back out in the field. So that's how we do a heat map. And this more or less concludes the training on the right-hand side of IMS.
Bloody marvellous. Thank you, Acea.
Awesome. That's all right, mate. Yeah, let's schedule another one for the left-hand side and hit me up if you've got any questions.
Yeah, no, that was really thorough. Thank you so much. Yeah, I'll be keen to go through just like setting up the graphs, etc. For new customers and everything I need to know there in the over in the stat browser panel.